Welcome students. I am going to explain Python program to operate stepper motor using Adafruit Library. Okay, so before this we will see a little bit about the stepper motor. So see, first of all see what is stepper motor. So stepper motor is an electromechanical device which converts electrical pulses into discrete mechanical movements. Then it's a brushless DC electric motor that can divide a full rotation into a large number of steps. Then a stepper motor consists of a permanent magnetic rotating shaft called the rotor and electromagnets on the stationary portion that surrounds the motor called the stator. Then the stepper motor may be used for locomotion, movement, positioning and many other functions where we need precise control of the position of a shaft or lever or other moving part of a mechatronic device. Now in figure you can see that this is the figure of your actual stepper motor. This is 6-wire stepper motor. So stepper motors are available in 4-wire format, then in 6-wire format, in 5-wire format. So there are different stepper motor available as per their number of wires. So but we are having 6-wire or 6-cable stepper motor, which is unipolar stepper motor. Then this is the diagram of our permanent magnet stepper motor, because we are using permanent magnet stepper motor in our assignment or in our kit. So here you can see that this part is stator, which is having these windings or coils like this. You can see that numbers are given here 1, 2, 1, 2, and in between these coils or windings there is your rotor, or that is also called as permanent magnet. Okay, rotor. So on which rotor there are permanent magnet poles available, like you can see that there is north south poles are available here. So this way your permanent magnet stepper motor is used in our assignment, so that we have to use and we have to rotate a rotor with the help of electromagnetic induction principle. So after that we can say that in short we can say that our stepper motor which converts electrical pulses and then it leads to the mechanical movements with the help of electromagnetic induction principle. So it uses different steps that we have to say. So after that we'll see stepper motor types. So here I have listed some types. So you can see the diagrams of or figures of that types of stepper motors. So first this you can see that there is from this way you can see there is a permanent magnet stepper motor where you can see that there is a permanent rotor, magnetic rotor, and surrounding which there are the windings or coils. Again there is a variable reluctance stepper motor which has a rotor and which is surrounded with many coils, but its rotor is having a gear, or which is having threads. Okay, which is having multiple threads. So after that the third type is hybrid stepper motor, which is the combination of your permanent magnet stepper motor and variable reluctance stepper motor, which is having, again you can see that it is having a small threads for high performance of the stepper motor. So after that your stepper motor is using 4 types of stepping modes. So first is wave drive, where in wave drive stepping mode one phase will be on at a time only. So you can see that what is phase is here this winding. This particular winding is called as phase. So in wave mode, to rotate this shaft or this rotator, the one phase or one coil will be on at a time. So alternatively these coils will be on and off, and this rotor will be rotated in that direction. So this is the first stepping mode, that is wave drive, where one phase will be on at a time. After that, next stepping mode is full step drive, where two phases will be on at a time. Alternatively, two phases will be on. Here you can see that two phases will be on, something like this. At one time, phase number 1 and phase number 2 will be on here, and after that next time the phase number 2 and 1 will be on. After that phase number this 1 and this 2 will be on, and again this 2 and this 1 will be on, to rotate this rotor or this permanent magnet rotor. So this is about your full step drive, where two phases will be on. After that, third stepping mode is half step drive, where firstly there will be one phase on, and after that two phases will be on, and this will be alternative every time. One phase will be on, then next time two phases will be on, again one phase will be on, and then two phases will be on. That will happen in half step drive. And then in micro stepping, so in micro stepping, there's four type of stepping mode, in which it will apply continuously varying motor currents, so that this rotating shaft will move smoothly, or will move in small stepping angle. So you can see that what will be the difference between all these stepping modes. So there will be there is a difference between difference about the step angle. So what is the step angle? The movement of your rotor in a particular angle is called as step angle. When we apply power to the windings, at that time these poles will be attracted towards these poles will be attracted, or this rotor will be attracted to the windings with the electromagnetic induction, and at that time whatever movement is done by this rotor in some angle, that angle is called as step angle. So you'll get idea about that. So by default we are using permanent magnet stepper motor, which has 30-degree step angle. Remember this thing, because you have to use this step angle in your program. So that once again I am telling you, that is our stepper motor is using 30-degree step angle. So that is said by the manufacturer. We are not defining it. We can change it, but we have to use the different step modes there. But we are going to use here full step mode, full step drive, that we are going to use two phases on alternatively in our program. So remember that thing, that one thing is that we are going to use 30-degree step angle, and we are going to use full step drive stepping mode. So next, the applications of stepper motor. So there are wide variety applications of stepper motor, in which you can find your printer, your stepper motor in printers, plotters, then high-end office equipment, then hard disk drive, then medical equipment, then fax machines, then automotive, and many more applications are available there, which are using stepper motor for movement, for rotations. So this is about your applications of stepper motor. Then you can see this the small table of 4-step sequences. I told you that we have to use 4 steps. We are going to use here 4 coils, and where we are going to use full step drive mode. So for that purpose, this table shows the 4-step input sequence, that is called as full step mode, where you can see that these are phase 1, phase 2, phase 3 and phase 4, or you can see that this is coil 1, coil 2, coil 3 and coil 4. where what are we doing? That is, in step 1 we are doing our coil 1 and coil 3 on, and other coils will be off. And step 2 we are making our coil 1 and coil 4 on, and other coils will be off. In step 3 we are making our coil 2 and coil 4 on. In next step we are making our coil 2 and 3 on. So this way your step will go repeatedly, and you will get your rotation, you will get your single movement. So that we'll see in the program in detail. So this is about your stepper motor, its types and its stepping modes and its applications and its full step mode. So we'll see now the program. Okay, so now I was explaining about the flow of writing the program. So first of all, I told you in the last videos as well that step 1 is that import the libraries such as Adafruit _BBIO, time, etc. So that libraries you have to use first. After that, in step 2 we have to do pin assignment with variables. Now you can see that we are having 4 variables, and why we are having 4 variables? Because we are having 4 coils. So these 4 pins are of that 4 windings or 4 coils that we have to use in our program to make them on and off. After that, in step 3 we have to define function for switching on and off coils. So for switching on the coils and switching off the coils, we are going to define 2 functions. One is coil on and another is coil off. After that, in step 4 we are going to define function for step sequences, because I told you that we are having 4 step sequences. We are having 4 steps in which we are going to on and off our 4 coils. So you can see that for making 30-degree angle, we have to already I explained this. So based upon that, I told you that I converted that numbers or that events into binaries here, and after that I converted that binaries into decimals. Here you can say that we are going to use a step sequence 5. So 5 is represented in binary like this, 0 1 0 1, where you have to start your coil numbering from LSB side. So here you can see that we are going to make our coil 1 and coil 3 on, and after that we are making our coil 2 and 4 off. Same for your 9, 10 and 6. You can read that because I already explained that, so that you can understand very well. So this sequence we have to use, that is 5, 9, 10, 6, so that our stepper motor will rotate, or so that our rotor of the stepper motor will do a single movement, will do a single movement. So after that, in step 5 we are going to define function for rotating stepper motor in anti-clockwise and clockwise direction. So that for that purpose we will define anti-clock W function and clock W function. And in step 6 finally we will define the main program or main logic, in which we will call our anti-clock W function 12 times to make a 360-degree complete rotation in anti-clockwise direction. And again we will call this by mistake I made here. Okay, so in second we are going to call clock W function 12 times to make a 360-degree complete rotation in clockwise direction. So I told you already that we have to use step angle here. So here you can see that for making a 360-degree rotation or 360-degree rotation, complete rotation, we have to, how can we calculate this? We can calculate by using step angle. We have to use step angle, and this step angle you have to multiply with pulse rate. Now what is pulse rate? That is your number of steps, or that is your number of times you are moving, you are rotating, or you are you are placing your rotor, you are moving your rotor, so that is called as pulse rate. So how many times you are moving your rotor in 1 second, that number of times are called as pulse rate. So here how can we determine pulse rate? So by dividing 360 by step angle. Now we are having step angle, that is we are having step angle 30 degree, and we'll just divide 360 by 30, so we'll get 12 value here. So whenever we are going to call our anti-clock W and clock W function, that we have to call 12 times. Why? Because we need pulse rate 12. So this way the stepper motor assignment is there. So now we'll start the actual programming. So we'll start. So first we'll type the command. So third I will implement the font size. So first type vi command in our Beaglebone terminal. So vi, then step.py, I will give the name this file. After that, first I will use shebang character to provide the binary path of record. After that, first step is what? That is import libraries. So that we will import Adafruit underscore bbio.gpio as gpio. So after that we will use import time. The next step is what? That is pin assignment with variables. So we'll directly copy and paste this pin assignments. So these are the 4 pins that we have to use. Okay. So these 4 variables we have used, that is W1, W2, W3 and W4. So next thing is, that is define function for making coil on and off. So we will define first function, that is def coil on, in which I will pass pin parameter. So that we have to we have to provide the pin number as an input here. So here this definition is very similar to your LED on and LED off function. So first we'll set up the direction with the help of setup function. So gpio.setup will call setup function, and in between parentheses we'll use pin input parameter. Again we'll set the direction with the help of gpio.out, because we are going to use here coils for output purpose, or we are going to use a stepper for output purpose. So after that we'll use output to write the value on that pin, and after that we'll write high for making coil on. So that return. So next function is your coil off, where again we will use pin as an input parameter. Now I am going to copy the code here. So just copy and paste here, because the definitions are same, just a little changes here. That is, in place of high we have used low to make our coil off. Other things are same, that is setup is same and other things are same for output. So this is about your coil on and coil off, where your stepper motor coil will become on and off. So next function definition, that is define function for step sequences. Okay, so I told you there are 4 step sequences, that is 5, 9, 10, 6 that we have to define here. So why we are given 5, 9, 10, 6 names them? Because based upon their binary values, which will which are representing the coil numbers. So first we'll define def sec phi. We'll just give sec phi. So here we don't have to use input parameter because here we are going to call our coil on and coil off function. So for sec phi function, now we know that we are having 0 1 0 1. So in comment I will write the binary so that we will get idea about this. So 0 1 0 1 is required here. So that what we have to do, that is we have to make coil 1 on and coil 3 on. So we'll write it here. So we'll call coil on first, and here we'll use W1 as an input. After that we'll provide a time of 001. So 0.0001 small time will provide here, that microseconds. Then we'll call coil off for making coil number 2 off. Then we'll again provide time 0.001. Then after that again I will just copy it because the other things are same. So I will copy it, I will paste it here. So just paste it here because things are very similar, so no need to type code again. So we'll just change here. Now we are to on coil number 3. So after that again we'll paste the same code here. That is, now we have to make our coil number 4, that is W4 off, and again the time will be same here. So this way we have defined the function for sequence phi. Now we will define function for next step sequence, that is 9. So the binary of 9 is 1001. So now we will define def sec 9. This will be the name for that function, and after that here the definition is same, just we have to change the sequence of on and off. So we'll paste this function definition, whatever we have defined first. So now coil 1 we have to start make on, so the function call will remain same here. Then coil 2 we have to make off, then coil 3 we have to make off, and then coil 4 we have to make on. So this way you can do the change. Now the next step sequence is 10. So here we will use 1010 binary, and we'll type def sec 10, and then same code we will copy here and paste here. So just copy and paste here, and now change. So now here we have to make coil 1 off, so we'll make it off. Then coil 2 we have to make it on, then coil 3 we have to make off, and coil 4 we have to make on. So that's correct. We'll go for next step sequence, that is 6. So its binary is 0 1 1 0. So starts from LSB and then try to make them on and off here again. So step sequence 6, for that we'll again we already copied the code. Now again I will paste the code here. So here we will make the changes. Now see, coil 1 we have to make off, then coil 2 we have to make on, then coil 3 again we have to make on, and coil 4 we have to make off. So this way we have defined the functions for step sequences. There are 4 step sequences, 5 9 10 6. Now we will define function for direction. So there are 2 directions. one is left and other is right direction, or we can say that one is anti-clockwise direction and other is clockwise direction. So we'll define function def anti-clock w. Okay, so after that we'll call just our step sequence functions. Now I told you that to make a anti-clockwise rotation or movement, we have to call our step sequence like this: 5, 9, 10, 6 in this order. So I'm writing the step sequence in comment like this. So 5, then 9, this 10, then you have to call 6 for anti-clockwise direction. So that you can call your function, that is sec 5, then provide a time of 0.01, then you can call step sequence 9, call it here, again time for sleep and 0.01, then call sec 10 function. So here again use 0.01, then call sec 6 function here and provide time dot sleep 0.01 and then return. So this way you can define function for anti-clockwise direction, and where you have to follow 5, 9, 10, 6 sequence. Now the next function for sequence, or here we have to define function for clockwise direction. Now for clockwise direction we have to make this sequence in reverse order. Now we'll call our functions in reverse order, or we'll use the same sequence in reverse order, like we'll call first 6 and then we'll call then 10, then we'll call 9 and then we'll call 5. So for clockwise direction, so here we'll define def clock w function, where we'll just copy paste this code, because you have to change just numbers here. So I will paste and I will write here the 6, then 9, then 10, 6, 10, 6, 10, then 9 and then 5. So this way you can call the functions in proper sequence, that is 6, 10, 9, 5 sequence we have to follow here for clockwise direction. Then the next step is define main program or main logic. Now through main logic we will first print Python program for slipper motor. So define it. After that we will display a line like this. After that we will use while to infinite loop will use, and then we will call the function, but before that we'll print stepper motor rotating in anti-clockwise direction. So we'll display this, and then we'll call our anti-clock w function 12 times within the for loop in range, so 0,12, and then we'll call anti-clock w function here. Then we'll provide time dot sleep of 0.1 second. Then we'll use for I in, but before that we'll again print. I will just copy this statement, or this will copy. So here we'll change it by clockwise direction, and here we'll change this anti-clock W with clock W, and remaining thing will keep it same. We will just use 2 here and just 2 here. So this way you can use, or you can define, you can write your program for step promoter. Now I'm going to execute this program. So escape, then colon wq. So python step.py. So before that I will make connection. So for that I will make connection, and I will just make it here. So then we'll start, we'll make it here, so that you will get here, so that you will get the real time output here. So you see what is happening, what will happen here. So that this is the step promoter, you can see now it is in initial position. So now I am going to run this program. So you can see that this stepper motor is rotating in 360 degree. First it is rotating in anti-clockwise direction, then it is rotating in clockwise direction. So thank you for watching my video.